Hello students. So in today's session we'll be discussing about Hive. Well, what is Hive? As the term goes, it's a very interesting concept. It basically works like a particular database. You want to work with it and you want to create and you want to gel with it. You want to work with the transaction purpose and all those things. That is what basically Hive consists of. So it also provides a Hive query language, HQL, what you call it as, which is almost similar to the structured query language. But why that's the difference? Well, we need to know that. Okay, why there's a difference and why we are trying to work with this particular point. Because already we have SQL, then why HQL? Yes, HiveQL, what you can say. So we'll try to understand that as we'll be discussing about the details, that is what do you mean by Hive? Okay, what made it come into the picture? Then we'll try to understand what are the features, okay, what are the particular services involved in that, okay, what is the architecture of Hive, and we'll also try to work with the data types. Okay, so initially we'll just try to understand the overview about it, and then the major point what we need to understand here is how well we can install and implement the Hive. Well, that would be another session. This session will be only comprising of the services, the features, the architecture of Hive, the data types. These are the major points which will be covered up in this particular video. Now, as we say here, we already know that we have learnt Hadoop. Hadoop is a framework that handles huge volumes of data sets in a distributed computing environment. Okay, so we are trying to talk about the details, how well we can handle it. Okay, now in fact these data sets can be in any form, unstructured or structured. So we are talking about a distributed computing environment, and in that we are talking about the particular data set which is in any form, either unstructured or structured, and that is where we need to highlight what is the picture or what is the introduction of Hive. So to carry out operations like querying and analyzing on such huge amounts of data, Hadoop offers an open source data warehouse system called Hive or Apache Hive. That is the point you need to make a note of. Okay, so why we are talking about Hive? Well, to manage, handle large data set which are in any form. Okay, it may be a structured or unstructured, any of these, and we need to manage them by querying it, by analyzing it and proceeding it ahead. Now, Hive is a mechanism through which we can access the data stored in HDFS. Okay, so with this small point, I would like to tell you what is the definition. Okay, so basically what we say, it is a mechanism through which we can access the data stored in HDFS. It provides an interface similar to SQL, which enables you to create databases and tables for storing data. So what is happening? We're just basically trying to make it work with the database transactions. Well, the idea here is to implement the larger data set. Okay, to handle, to what you can say, control the larger data set, we are trying to use the HiveQL. Okay, now Hive is a data warehouse system which is used to analyze structured data. It is built on top of Hadoop. It was developed by Facebook. Okay, so this was the initial point. Of course, apart from that, it also says that we are trying to access the data stored in HDFS. Okay, so it is providing an interface. So Hive provides the functionality of reading, writing and managing large data sets residing in distributed storage. So this is the point which will clearly tell you what we are trying to work with. The functionality of reading a particular data set, writing a data set, or you are trying to update, or you are trying to alter, whatever changes you want to do, managing that large data set will be residing in a distributed storage. Okay, so it runs SQL like queries called HQL, Hive Query Language, which gets internally converted to MapReduce jobs. Now this is where it's a fascinating point. Okay, so here we have a particular phase which will be transferred from one to another. We are writing all the particular query language. Okay, it may be HQL, but what happens? It will be internally. Okay, not your job. Okay, internally converted to a MapReduce jobs. That is how the later part of the Hadoop framework will be carried out. Okay, that is the point to be noted. So using Hive, we can skip the requirement of the traditional approach of writing complex MapReduce programs. So what was happening in the MapReduce particular details, we saw that, right? What all things to be, well, you need to work out with that. Yes, so you had to work out with the mapper class, you had to work with the reducer class, you had to manage the task, you had to work with the prioritization, okay, resource management, all those things had to be worked out in detail when you have to work with the MapReduce programs. So all those complexity will be reduced when we use the Hive part of it. Okay, so that is what is the traditional approach can be skipped. So Hive supports data definition language and data manipulation language and user defined functions. So a very important point. Okay, so before we move on, a quick point, that is SQL. Well, what is SQL? Same thing. SQL is a structured query language having data definition language in it. It has data manipulation language in it. Okay, these two things are also present in SQL. I hope SQL is known to you when you come towards HiveQL. Okay, SQL is a very important point to be taken care of. Yes, so it's a database concept. You need to understand what is structured query language, how exactly you are trying to create a database. After creating a database, you are trying to understand how you are trying to populate the database, that is creating the tables. After creating the tables, you are trying to insert the records into that or tuples into that. After inserting or creating the tables, next point is you need to understand, is the data properly handled? Okay, but what happens in SQL, as I said, it's a structured query language. Okay, we are talking only about the structured part of it, structured form of data set, whereas HiveQL is used in both manners. Okay, but basically we use HiveQL for, there is a major portion is used for unstructured data part of it. Okay, so that is what is the point to be taken care of. Of course, as I said, you are trying to create tables, you are trying to insert the records into that. After the table is populated, the next thing is what? You are trying to just work with the fetching of data. Okay, well, fetching of data in a huge, large volume of data is the point to be taken care. That is where you are trying to make it more important. That is where you have to work harder to get it done. Okay, well, work harder means the software or the platform will help you to do it. You have to just implement a simple thinking on it, simple logic which has to be implemented. That's the difference what you can make out even if the data is in large volume. Okay, now as I said this, we have to talk about some more points, that is basically remember that the MapReduce concept will be achieved explicitly writing the source code for it. Okay, so what is happening in this? As I said, you are trying to get internally converted to MapReduce jobs. That is another point to be taken care of, a very important note. Okay, so Hive also supports a language called HiveQL. Okay, that's what I said. Now, as we said, DML, DDL, there's one more, that is user defined functions. So we have here an additional feature called as user defined functions, and that is what you can implement directly. Okay, so I will not tell you what is UDF. It's a user defined function. You can just write it and you can work on it. That is what is the point to be taken care of with the Hive. Now, basically when I say Hive, the point here is, so Hive also supports a language, as I said, HiveQL. It is considered as the primary data processing method for treasured data. Okay, so treasured data is a cloud data platform that allows you to collect, store and analyze data on the cloud. So this is another point to be taken care. So we are talking about another feature, another component, that is cloud. So even a cloud part of which is to be implemented, and we are trying to work on that. Okay, so it manages its own Hadoop cluster which accepts your queries and executes them using the Hadoop MapReduce framework. HiveQL automatically translates SQL-like queries into MapReduce jobs executed on Hadoop. That is the point you need to work out. Okay, so with this additional points, we'll just go ahead with the features of Hive. Okay, now what exactly we are trying to focus? Yes, what are the major features? Of course, Hive is fast and scalable. That is a very first and foremost point to be taken care, because it has to be fast, as we are having a large amount of data and you are trying to work with a huge data set. Okay, along with that, you need to make a note that it is a distributed environment. Hive is implemented on a distributed environment, so you can just understand at what level they are trying to achieve it. Okay, so that is the point to be taken. And scalable. Scalable, how well you are trying to understand each and every distributed environment having a n number of nodes in it. Okay, servers, how well they are trying to have a control, have access over it, how you are trying to have the transaction between them. That all things should be covered in this. So Hive is having these features. It is fast and is scalable enough to make a note of all the particular nodes present in that. Now, it provides SQL-like queries, that is called as Hive Query Language HQL, that are implicitly transformed to MapReduce or Spark jobs. This point is very important to note, because as I said, we are talking about a particular query language, you are writing all the queries, you are trying to perform them, but what exactly happens at the background? Well, at the background, you are trying to get it transformed into a typical Hadoop structure, that is the MapReduce kind of program, kind of MapReduce structure. So as it says, MapReduce or Spark jobs. So how exactly the MapReduce job do? How they are trying to perform? Well, we have discussed it in the previous session. So on that basis, the MapReduce jobs are being taken care, and you are trying to implicitly work on it. Okay, so this is the point you need to work. Okay, so that is the second feature. It will be either MapReduce or Spark. Spark is another framework which you need to go through it. Okay, so this is how it tries to work on it. So it is capable of analyzing large data set stored in HDFS. So we are talking about the Hive, which is connected with the HDFS, Hadoop Distributed File Systems. Okay, so you can just imagine the HDFS architecture, in that what all components are involved in it and how exactly Hive should be placed. Okay, so I will be discussing the architecture, but initially this is the component which is required. So you are talking about the analyzing it, and that is a major functionality. The function is to analyze a large data set, okay, and is capable enough to work on it in a HDFS concept. Now, it allows different storage types such as plain text, RC file and HBase. Okay, so this is how you are trying to work with the particular storage types. Okay, so it can be any of these three and which you can perform. So I will be talking of these different storage types in the later stages, but this is what is the point to be noted. Okay, so it uses indexing to accelerate queries. Well, when I say indexing, basically you are trying to improve the efficiency of having the queries performed rather quickly. Okay, because when you are trying to shoot a particular query, what happens? You are trying to generate a set of data. You are trying to fetch a data, right? So where is that data available? Where is it situated? Are you trying to apply it in a proper way? Because when you are having hundreds of records, and if you want to get the 95th record, then you have to imagine how much time it requires to go one by one, right? Well, when I provide a particular indexing concept, it becomes an efficient way of handling it. Okay, so indexing will just help us to quickly move across the records and get it, because we are not talking only about 100 records, we are talking about millions of records. Okay, in that millions of records, you have to fetch a particular data. So how much amount of data has to be taken care? How much amount of time has to be noted? So that is what is the point to be taken care when we use indexing. So indexing is a very vital point where it helps us to accelerate the queries. The transactions happen much more faster. Okay. Next, it can operate on compressed data stored in the Hadoop ecosystem. So what makes it much more fascinating is basically when we talk about the operation on compressed data. Okay, so we are talking about the Hadoop ecosystem. So Hadoop ecosystem, you know how many platforms environments are available in that Hadoop ecosystem. In that, the compressed data, what is stored, we are trying to work on it. Okay, so it can operate on compressed data. So it is available with the compressing, uncompressing concept and working on it. Okay, so that is another feature which is very important to be noted. Okay, well, next it supports user-defined functions where users can provide its own functionality. So a particular person can just come up with its own functionality. Okay, suppose you are trying to write a function to get certain amount of data and you are trying to work with the count of it. Okay, so you have a particular inbuilt function to count the number of records. Okay, but similarly if you want to work with a user defined functionality, suppose you want to work with two different counts, how you can work it? That is how you can perform the user defined functions. Okay, trying to get certain methods to just know if a particular employee, okay, what is the salary, okay, whether he has to be included. Okay, before including you have to check any particular functionality that the salary should be more than 10,000, then only the employee will be injected or induced into the salary list. Okay, so that kind of user defined functions you can provide. Okay, so these are the very basic features which are provided with the Hive. So these all will help you to understand as and how we work with the implementation concept. Okay, so there's one more point which you need to look out here is that Hive is not a complete database and is not meant to be used in a online transaction processing system. Okay, such as online ticketing or bank transactions. Well, I'm talking about the limitations. So we'll just have a particular slide working on that. So what it says, limitation, Hive is not capable of handling real-time data. So as I said, it is not working on the online transaction processing, OLTP concept, like ticket booking, bank transactions which are very interactive. Okay, online we cannot do it. Next, it is not designed for real-time online transaction processing, and Hive queries contain high latency also. So this is the point you have to work. So it is mostly used in data warehousing kind of application. Okay, so where you need to perform batch processing on a huge amount of data. So typical examples of this kind are like web logs, call data records, or weather data, and so on. So this is what is the point to be taken care. Okay, so the latency period is also increased because of the overhead involved in the startup. That's why it says high latency. We are talking about a large amount of data, okay, and that amount of data is being processed in a batch. Okay, so what exactly we need to work here is it's a data warehouse kind of application. Okay, so it will be initially it takes a lot of time because the batch has to be completed, right? First, as I said, it's fast. The batch processing also can be done in a faster way. Okay, now as it says, the latency is high because it increases the overhead which is required at the initial point. Okay, this means that queries that usually take around a few milliseconds to execute in traditional will take more time. Okay, well, these are some limitations, but these are regarding towards the particular point only, because we are trying to work with a large data set. The SQL cannot be implemented on the unstructured point of view. Okay, whereas here we can do it. So just make a note of those points. Okay, so that's about the limitations. Moving on to the quick point, that is difference between Hive and Pig. Well, we are having certain introductory points of Pig. So I have taken this particular slide where we can talk about Hive is commonly used by data analysts. Okay, so the data analyst people will try to use the Hive concept because the analyzing is important here. You are trying to analyze the data and perform on it. Whereas Pig is commonly used by programmers. So Pig is basically towards the programming part of it. So it follows SQL-like queries, it follows the data flow language. Okay, you are trying to have a particular flow from A to B, B to C, C to D, and the output. It can handle structured data, it can handle semi-structured data. Okay, so it works on server side of HDFS cluster. So it is on the server side, whereas Pig, it works on the client side of HDFS cluster. So you can just imagine, well, there are differences, but they need to go hand in hand and perform. Hive is slower than Pig, Pig is comparatively faster than Hive. Okay, so a quick point so that we can just know what is the point, and I'll be correlating it later when we talk about the Pig. Now, the next point which we need to talk about here is the architecture. So the following architecture explains the flow of submission of query into Hive. So basically you can see here there are 4 parts. Okay, that is 1, 2, 3 and 4 which has been divided. Okay, so we have at the bottom that is HDFS, on top of it we have MapReduce, then we have Hive services. Okay, we are talking about Hive services. Yes, this is a point to be taken care. So what happens when I say Hive services? It is having certain components which are very much important for us to work on that. So Hive web UI user interface, Hive server is there, then CLI command line interface is there, we have Hive driver, then we have meta store. Okay, so we are having basically 6 points which are to be taken care. Okay, now sorry, 5 points which need to work out. Okay, that is web interface, server, CLI, driver and meta store. Okay, now how exactly it tries to perform is this components allows you to submit queries to the Hive system for execution, that is the user interface. Okay, so we'll check one by one what exactly each of these particular point mean, and we have Hive client which are basically the points to be connected to the server. So we have thrift server, JDBC or ODBC servers. Okay, sorry, drivers. So we have thrift server, JDBC driver and ODBC driver. Okay, so this is what the client will try to communicate to the Hive services. Hive services will be sending it to the, or internally it gets transformed to MapReduce job which will be communicating with the HDFS and doing the job. Okay, so we'll go one by one what exactly each of these particular points or components mean. Okay, so Hive client. So Hive allows writing applications in various languages including Java, Python and C++. So it supports different types of clients such as thrift server. So what is thrift server? It is a cross-language service provider platform that serves the request from all those programming languages that supports thrift. Okay, thrift is basically a platform, okay, which is a cross-language service provider kind of one. Okay, so you can have any particular language which can be, the program can be written and you're trying to post it. Okay, so basically what you're trying to post is you're trying to send a request, so that can be managed. Okay, so serve the request from all those programming language that supports thrift. Okay, so that is one. Then the JDBC driver, it is used to establish a connection between Hive and Java. It is used to establish a connection between Hive and Java application. The JDBC driver is present in the class which is org.apache.hadoop.hive.jdbc.hive driver. So this particular class will be having the JDBC driver which we need to work. Okay, then we have the ODBC which allows the applications that support the ODBC protocol to connect to Hive. So the first one, basically the thrift is to understand the cross-platform or cross-language service providers kind of thing. Then we have the drivers, that is JDBC and ODBC, so that we can establish the connection between Hive and Java applications, and ODBC protocol get connected to Hive. Okay, so this is what is the Hive client which are to be taken care. Then we have the Hive services. So in Hive services, basically we are talking about the Hive CLI, that is the command line interface, is the shell where we can execute Hive queries and commands. So it's a very straightforward point. You are trying to use a CLI, command line interface, through which you can start off with your execution. Okay, so the queries and the commands can be executed through that. Then we have Hive web user interface. So when I talk about this Hive web user interface, so it says it is just an alternative of Hive CLI. Okay, instead of going through the command kind of thing, you're just trying to have a simple GUI, okay, web-based GUI of your executing the queries and commands. That is what is the point you need to look out. Next, we have Hive Meta Store. Okay, that is what is the point you need to note. Okay, so what happens here is basically you are trying to store all the information related to the structure of the various tables and partitions in the data warehouse. So a meta store is basically a central repository, as the term goes. It's a meta store. So it is a central repository that stores all the structure informations of various tables and partitions in the warehouse. It also includes metadata of column and its type information, the serializers and deserializers, which is used to read and write data, and the corresponding HDFS files where the data is stored. So what is happening here? We are just having not the tables and partitions in the warehouse, but also about the columns and its type information. That is basically when you talk about the unstructured part of it. Okay, so we are talking both. Okay, we are talking about structure information having its detail and the unstructured column and its type of information, and it also has the serializers and deserializers. Okay, so all these are related to the NoSQL kind of concepts. Okay, now the next point is Hive server. So when I say Hive server, what exactly it consists? It is referred to as Apache Thrift server. It accepts the request from different clients and provides it to the Hive driver. So it is having a protocol. Hive server will be having a particular medium in which it is trying to understand the Apache Thrift server, so that can have a proper communication established. So that is why we are trying to have a Hive server in it. Okay, so once we have that, next what we do here is we'll be having Hive driver, which receives query from different sources like web UI, CLI, Thrift, JDBC, ODBC driver, and it transfers the queries to the compiler. So why Hive driver is there? We are trying to use it for moving it from one, that is from the different sources, and transferring it to the compiler so that it gets compiled. So Hive compiler, the purpose of the compiler is to parse the query and perform semantic analysis on the different query blocks and expressions. So we'll be having a compiler which will try to parse the query and perform a particular semantic analysis, okay, on each and every different blocks which are available and expression. So it converts here, the compile after this, the HiveQL statements into MapReduce jobs. So basically when I say driver, which will be having a query compiler and executor. So this particular driver and compiler will try to execute the particular query by compiling, by parsing it. Okay, so once it is parsed, it will come to what all things have to be taken care of. Okay, it tries to divide, it tries to understand each and every block in it, the expressions in it, and that will be further moved to the MapReduce job. So when I come towards this particular point, when I say MapReduce, what happens? I am talking about a job tracker and a task tracker. That is what is the conversion is to be noted. So when I say it converts HiveQL statements into MapReduce jobs, it is basically trying to understand two things now. That is a job tracker and a task tracker. Okay. Then it goes to the Hadoop and the HDFS. Before that, there is a particular Hive execution engine. So optimizer generates the logical plan in the form of DAG. I told you about DAG also earlier. It's a graph. So basically I'll tell you that it's a directed acyclic graph. So when I say directed acyclic graph, it's a model for scheduling work. In this model, jobs are represented as vertices in a graph. So what is happening here? Jobs are considered or represented as a vertices in a graph. Okay, so there should be a vertex from one to another and it goes on. So there should be some sequence in which the jobs have been performing. Okay, and the order of the execution of job is specified by the direction of the edges of the graph. So how will you come to know that you have to flow in a particular way? You are trying to understand with the help of edges. That is why we talk about as a directed acyclic graph. Okay, so jobs are represented as vertices in a graph and the order of the execution of job is specified by the direction of the edges in the graph. So the term acyclic means there are no loops in the graph. Okay, so we are talking about a particular acyclic. There is no loop in a particular graph. That is what the DAG is a model. Okay, in that fashion, the logical plan is being set up. So the optimizer generates this logical plan in the form of DAG of MapReduce task and HDFS tasks. Okay, so this is how the DAG is being taken care by the MapReduce task and the HDFS tasks. In the end, the execution engine executes the incoming task in the order of their dependencies. So based on the dependencies, the execution will be happening. So this is what is the point you have to make a note of with respect to the following architecture. Okay, so the Hive client with the thrift and the JDBC server, ODBC server, I told you what all the points which are required for that. What do you mean by it? Then we have the Hive services with the web user interface. Then we have the command line interface. Then we have the Hive server and the Hive driver, and then we have the meta store which has to be taken care. Okay, so this is how the DAG will work in the model, so that the meta store is connected to MapReduce and then the HDFS to get the job done completely. This is all about the particular Hive architecture which you need to make a note of. Okay, so these are the points to be noted. So with this, we will move on to the next point, that is the last segment of the session, that is the Hive data types. Okay, so when I say this Hive data types, well, data types which were used in SQL also you can go through it. Which are the different data types which were there in SQL? You can just make a note of those things. Okay, you can just find out and check. Okay, starting from the varchar, integer, char, date, boolean, okay, and all those. Similarly, we have here, we just need to work out with that. Let's check out. Hive data types are categorized in numeric types, string types, that is miscellaneous types, type what you can say is. So miscellaneous types and complex types. A list of Hive data types is given below. So as you can see this, integer type will be having a particular type called as tiny int. Okay, so we'll be using a tiny int, a smallest of smallest data, that is of 1 byte signed integer. Okay, the range is -128 to 127. So here basically this kind of range has been handled by tiny int. Next we have small int, 2 byte signed integer, right from 32,760 to 32,767. Okay, of course we need to check with the sign, so it will be a negative and positive. Okay, so negative is here, positive is this side. Then we have the int, which is the 4 byte signed integer all the way from these particular integer values. So you can just imagine when I say int, what is the amount of digit which can be placed in it. Okay, so that is why you are talking about the large data set. And then we have the big int, which is this, the last column. You can just check the number of digits which can be managed. So this was the integer types. With related to that, we had tiny, small, int, big int. Okay, so as I said, tiny int, small int, and big int. These were the first set of data types with respect to the integers or numeric types. Then we have decimal type with basically float, with 4 byte, double with 8 byte. So single precision floating point number, double precision floating point number. Okay, similar to that kind of range. Then we have date time types. Okay, so that's a very important thing because you are trying to work with the particular large data set which are unstructured on what particular date this type of data was executed. So a date will be a vital one to be noted. So date and time types. Timestamp. It supports traditional Unix timestamp with optional nanosecond precision. So you can just think how we are trying to work with this. Okay, so it is working with the nanosecond precision also. Okay, but it's an optional one. As integer numeric type, it is interpreted as Unix timestamp in seconds. As floating point number numeric type, it is interpreted as Unix timestamp in seconds with decimal precision. Okay, so as string, it follows java.sql timestamp format, which is very much similar to this. That is 4y hyphen double m hyphen double d space double h colon double m colon double s dot the decimal values. That is another point of it. That is microseconds which you want to work. So it is having a 9 decimal place precision which is to be taken care here. Okay. Then the date value is used to specify a particular year, month and day only in the form of 4y double m double d. However, it didn't provide the time of the day. The range of data type lies between the following range. You can see that. Okay. So this is the range in which the data type or the data can be utilized of date. Okay. So that was the point when you talk about the timestamp with respect to the date and time types. So the second last, is the string type. The string is a sequence of characters. Values can be enclosed within single quotes or double quotes. So the values are basically enclosed as you do it in SQL also. Similarly, here also you can work out with the single quotes and double quotes. Okay, so it's a sequence of characters, string. Then we have varchar also here. So varchar is a variable length type whose range is between 1 and 65,535, which specifies that maximum number of characters allowed in the character string. So this is the length type in which you can utilize it. Okay, last is basically the char, which will give you the char is a fixed length type whose maximum length is fixed, that is 255. So varchar is a variable one, char is a fixed one with the range which has been provided. One is 1 and 65, 535, whereas in fixed it is up to 255 only. So this is the string type which you need to go through. Coming towards the last part of it, that is the complex type. So this is also a part of data type in Hive. Okay, so the type is struct. It is similar to C struct or an object where fields are accessed using the dot notation. So using the dot notation, I can access the fields. Of course, the ranges, you can see a struct with 2 columns, James and Roy, which are provided in a single quote. Remember that. Okay. Next, map. It contains the key value tuples. So we are having a particular complex type called as map, which contains the key value tuples where the fields are accessed using array notation. When I say array notation, it will be the kind of arrow. Okay, so that is what you are trying to use it. So map, we are having a key value kind of thing. First name, that is what is written in quotes, then James. So first name is James, last Roy. So key and value. Okay, that is what is the point you have to make note of. Yes. So map is similar to the map reduce concept. So next we are trying to. So that's the inbuilt part of complex type. Map has been directly implemented and you have to perform it. Okay, the data type. Then we have the array. It is a collection of similar type of values that indexable using zero-based integers. Okay, so it's an indexable one which is starting with a zero-based integer as you use it in C. Okay, arrays, and you can just similar type of. That's the only difference. Okay, we'll be having a homogeneous part of it. Okay, so array and in bracket you are just trying to give it similar James and on the similar kind of data type or the type which has been mentioned in the array. So these are the points which you need to know and understand when we talk about the following hive details. Okay, so the complex type is also available. With this, the initial part, that is the overview about the hive with respect to the definition, with respect to the understanding the features, the services, okay, and also to work with, understand the architecture of it. All these details with data types, okay, were discussed in this session. Well, the next session will be consisting about more details, that is regarding towards the hive commands used for the interactive mode, okay, which are those, then the hive CLI concepts, then we'll talk about the database creations, okay, what is the syntax for the creation of that database, how you are trying to use the commands in that, all those things will be checked, and also we'll be talking about the point, that is the installation, okay, how exactly it will be used for the installation purpose, what is the procedure. So all this will be taken care in the next session. For this session, that's all about the following set of points. Thank you. Take care.